Modular arithmetic. Great. That's lovely. How many hours work can you fit into one day? Not enough! There's always a sad remainder of unworked hours. Good things we have these optional night shifts to cram in more. For each two things in the inbox, outbox the remainder that would result if you had divided the first by the second. Don't worry, you don't actually have to divide, and don't worry about negative numbers for now. Told you overcomplicated it. I still did it in less steps, so it was faster. You need to go you need to watch some violence. Have fun. Okay, so I don't need to actually do division, which is good because the division algorithm with addition and subtraction is actually not nearly, it's not so bad. The multiplication is kind of the same thing. Because multiplication is just repeated addition and division is repeated subtraction. At any rate, how do we perform modular arithmetic with addition and subs? We just need to subtract over and over and over again, and then we'll get the remainder. Bear in mind, Purple, that this is a little bit different from, like, the division, you know, that we know in, like, in school. This is, like, modular arithmetic, so it's a little bit different. I'm calculating 7 mod 4, basically. Unless I'm supposed to be calculating 4 mod 7, but I don't think that's the case because a lot of these numbers are smaller than their second number. Alright, so 7 mod 4. Well, first, of course, we're going to inbox, and we're going to copy to somewhere. So that's one register. And we're going to inbox, and we're going to copy to another register. So this is... We'll go ahead and name this. So this is, so 1 is our mod underscore base. And this is our, we'll call this our rem. Alright, so we copied in 7 and 4. Then we subtract 4 from 7 to get 3. 7 mod 4 is 3. Is it expecting the entire remainder or a whole number? It's purple, this is what I was saying. So this is modular arithmetic. So 7 mod 4 is 3. And then 9 mod 4 is 5. And then 2 mod 9 is 2. So it's not you would think that you would get like a weird like floating point number and stuff like that, but thank God we don't have to worry about that. Hello, 7 wags. So we copy 7 into there, and then we need to... If our remainder is bigger than our modulus base, then we subtract our modulus base from our remainder. So we should be holding our modulus base. So we need to copy from our remainder and subtract our mod base from it. So we load 7 into the remainder. We load 4 in. We grab 7 and subtract 4 from it to get 3. 3 is 7 mod 4, so that's the correct value. And then we just need to set up our loops from this point onward. So, how do we do this? Okay, so this performs one step of our modular arithmetic. And this is, what I'm implementing here is like a small step algorithm, so it's going to just do one little thing. So yeah, we need to do a value check, of course. So we have 3, and we load that into the remainder. No. If it's negative, then that's one step too far. If it's negative, then we copy from our remainder, outbox it, and then jump to the start of our function again. If it's not negative, then we copy to our remainder, the current value. So 5 mod 4 should put down 5, then should put down 4 in our remainder, or in our base. We subtract 5 from 4. We load 1 in there. That worked well, but there was a check that it was supposed to do that I don't think it did. 8 mod 3, so this should give us back 5. Management expected 2. Oh, no, 8 mod 3 is not 5. What the hell am I saying? I'm sorry. People who know math were probably like, what the fuck did you just say? Okay, 8 mod 2 should be 0. So put down 8. Right, because it's not doing the check the way I wanted it to do. So that gives us 6. We load 6 into our remainder, and then we're just doing it the wrong way. Okay, that's fine. Yeah, I'm doing my check wrong. So let's run it again. This should give us a mod of 1, but it's not going to do it. Or just add from the mod base instead of copying from the remainder. That makes sense too, actually. Because that will just undo the the subtraction that we did. Which is fine. Actually, both approaches work better, but I think that adding would be just fine. So let's go ahead and run this again, and I'm gonna put it into debug mode and just step back to see where I messed up my logic here. So we did 3. So we jump if negative. We loaded 3 in, and that was not right because I am just jumping in the wrong ways. Because I'm putting this out box a little bit too eagerly. So we need to jump. Aha. We need to jump here. And then we copy from the remainder, subtract from our mod base, and do that. So I forgot one loop, basically. So we're going to call this mod step. So this performs one step of modular arithmetic. So we load in 5. We load in 3. 5 mod 3 is 2. We subtract 3 from 5 to get 2. We load 2 in there. We subtract 2 from 3 to get -1. And then we load our 2 into there. 8 mod 4 should be 0. So 8. Subtract 4. We load 4 into the remainder. We get 0. We can do 0 minus 4, so we just load that up. Okay, this is good. 3 mod 8 is 3. So it does -5, and then it just grabs the value, puts that in. 0 mod 3 is 0. Okay, cool. So this was a really, really weird one, but this worked out just fine. So that's the way to do modular arithmetic. I did a couple of extraneous copies, so there was actually a much more efficient way of doing this. Apparently not. In terms of size. In terms of speed, I guess there's a slightly different way of doing it. But that's cool, so that this algorithm is size efficient, at least. There's the copying is wrong, so there's a different way of doing this that doesn't have as many copies, which I guess takes more lines of code, but it runs faster. That's my guess. At any rate, there we go. Let's go ahead and move on to the next optional one. Remember last time I told you you didn't need to divide? Well, now you get to. For each 2 things, how many times does the second fully fit into the first? Don't worry about negative numbers, divide by zeros, or remainders. This might be a good time to practice copying and pasting from a previous assignment. So, effectively, when I was doing modular arithmetic, I was doing almost the same thing as this. So we're going to copy this whole program. And then we're going to paste it in, and that's going to be our start for doing a step of division. Hi, go, Mikesy. Okay, so we'll paste our program in, and instead of doing modular and base, 6 divided by 4 should give us 6. So what's this? What's the way that you do? How's the way to implement division with repeated subtraction? We have, instead of a modular base, we have a loop counter. So we say we just basically do subtracting 6 from 4. That's negative, so that's when we stop. I'm gonna need to do a couple of little like paper like back of the envelope maths here. 6 4 is equal to -2, so we stop. I'm gonna type this into chat so you can see the way that I'm just thinking this through. 6 minus 4 is equal to -2, so we stop. 8 minus 4 is equal to 4, so which is greater than 0. So we subtract. So we add to 0. Oh, that's why they give us a 0. Greater than 0. Increment results by 1. Store subtraction. Okay. So that's weird, half pseudocode, half nonsense, half bullshit, but that's what I was typing up. Okay, so let's go ahead, instead of this being remainder, this being mod base, we say this is our dividend, and this is our divisor, and then this is our res. So, I copied and pasted all this shit. I'm gonna clear it all. Whatever. So, first things first, we copy from 9, which I'm gonna go ahead and name that Z. We copy that into results. Then we inbox 6, copy to our dividend. You hate that you can't just type into the comments in this game. Yeah, it's kind of annoying that you can't just type, that you have to mouse art it. And then we copy by... This is second fully fit into the first. So which one's the dividend divisor? I don't fucking remember. So 6 is our... So how many times did the second fully fit into the first? So we're doing... So 4 divided by 6 should return 1 by that stupid logic. So 6 minus 4 gives us 1. Then 2 minus 4 gives us -2. So then it works. Okay. So we'll copy this into dividend and divisor. I don't remember if dividend and divisor, if I'm using these terms correctly. So sorry about that. But yeah. So the very first thing we need to do is subtract. So we'll currently be holding our divisor. So we subtract it from the dividend. And then if it's negative, then we copy from results and outbox it. And then we jump back to the start of our function. So this will right now this will return one. This will return one step of division, if I believe. No, because I'm not. Okay, so I need to jump over this. So we bump results, and no, we copy to dividend. And we bump results. I think this is correct. Is this correct? I don't know. So we load up 0, we put it in results. We grab 6 and put it in dividend. And we grab 4, put it in divisor. We subtract 4 from 6 to get 2, or -2. Okay. So I do have this backwards. So I think I need to... copy. I think I have my dividend divisor wrong. So we need to copy from dividend and subtract from divisor? Is that the way I should be doing this instead? Let's try this. I don't know. So we load up 0. We grab 8 and 3. We copy 8, subtract 3 from it, get 5. We load that in there. We bump that by 1, and then we outbox it. But that wasn't right. Copy dividends, subtract from divisor. Yes. Okay, cool. So that's been confirmed. My loop condition, again, I didn't do this right. I'm not jumping correctly. So I need to jump to here again. And let's go ahead and call this div step. This performs 1 step of division. So we load up 0. We grab 7. Then we grab 2. So then we subtract 2 from 7, and then we bump up results. We grab 5, subtract 2 from it, bump up results. Grab 3, subtract 2 from it, bump up results. And then we grab our result and throw it in there. Perfect! We did it! Yes, this is the algorithm. Alright, let's go ahead and just speed this up. It's gonna work perfectly. That was hard. Small divide. Let's see if I did this right. Yep, size challenge is correct. Speed challenge. Bam! I did it. That is, believe it or not, the actual perfect solution, apparently.